I forgot about D3. Okay, so we weren't quite done with example D. We have example D3. I've got two binomials. I'm going to FOIL, but they involve the square roots. And again, that is fine. We will take it one step at a time. We can do this. So first, I will multiply my 5 times my -4. Those are the first. This is, again, the FOIL method. First, outer, inner, last. So the first numbers in the parentheses are the 5 and the -4. They multiply and give me -20. Then I have my 5 times my 5i and the square root of 2. All right, so the 5 times the 5 will make 25. Okay, the I will just fall down and the square root of 2 will just fall down. So we have no like terms to put them with. Okay, so since I've sent the first number through everything in the second set of parentheses, now it's time for the second number to go to everything in the second set of parentheses. So the -5i and the square root of 2 times -4. -5 times -4, double negatives will make a +20. The I and the square root of 2 have nothing to combine with, but they are still there. So the I and the square root of 2. All right, -5i and the square root of 2 times a +5i and the square root of 2. Well, the -5 times the +5 gives me a -25. The I times the I gives me I squared. And the square root of 2 times the square root of 2 will give me the square root of 4. Definitely some simplifying we need to do here. I know that I squared is actually a -1, yes? And I know that the square root of 4 is actually the number 2. So what I have here is -25 times -1 times 2. So the double negative is going to make it a +25. 25 times 2 is 50. What this really is a +50. And then I will combine my like terms now that I have simplified. So the 50 will add up with the -20. -20 plus 50 gives me 30. And then these are actually like terms, okay? Because they're both the I and the square root of 2 and the I and the square root of 2. How many I's in the square root of 2's do I have? 25 plus 20 gives me 45. I in the square root of 2's. And that's that. All right, lastly, if you, again, these all came from IXL H3 underneath Algebra 2, which is the one dealing with multiplying complex numbers. So if you want to go for the 100, you're going to get to problems that look like this. Find the product means I multiply, of -10 plus I and its complex conjugate. New word, a complex conjugate. Now we talked about complex numbers. We said a complex number was in the form a plus bi, all right? That's my complex number. Its complex conjugate, so if a plus bi is my number, a minus bi is my complex conjugate, a minus bi. And you should notice the only thing that changed was the sign of the I, All right, my plus changed to a minus. That's it. So let's go to this little think cloud for a minute here. Okay, say I gave you 7 plus 2i. Its complex conjugate would be 7 minus 2i, right? All that changes is the sign of the I. Say I give you -11 plus 3i. Its complex conjugate would be -11 minus 3i. Notice I did not change the sign of the first number. If it was negative, it stays negative. The only sign that changes is the one in the middle. If I have a plus, it's going to become a minus. And in the same fashion, if it was a minus to begin with, its complex conjugate would be a plus. We get that concept? I hope so. All right. Now, the complex conjugates have a special relationship, which we will get more into when we go into division. But for now, we're just going to FOIL it out. All right, they gave me -10 plus I. That was my original number, -10 plus I. And they wanted me to find its product, I'm going to multiply by its complex conjugate. So its complex conjugate is negative 10 minus I. All right? Again, the only sign that changes is the one in front of the I. The negative 10 stays negative 10. If I want to find the product, I simply need to FOIL. So negative 10 times negative 10 is positive 100. Negative 10 times negative I is a positive 10I. And then it's the I's turn. Again, you can think of this as one I if you like. But the I times negative 10 is going to give me negative 10I. And the I times negative I times negative I, again, think of these as ones. It's a positive 1 times a negative 1, that's going to be a negative 1. And the I times I will be an I squared. All right, so I squared always changes the number of, or the sign of the number in front of it. Or again, we can think I squared is a negative 1. So what I have here is negative 1 times negative 1, which means this is really a positive 1. Yes? This is really a positive 1. And that 100 will add with that 1, which gives me 101. When I try to add up my i's in the middle, the 10i and the negative 10i cancel each other. And so 101 is my answer. That's it. That's all there is to it. I hope you understand. If not, text me on Remind.